Assalamualaikum and good evening everyone. My name is Muhammad Syahmi bin Muhammad SAGHIR. Here I want to show my results of my final year projects. First of all, I would like to introduce my projects, which is development of the LoRa based positioning system through the Internet of Things. The introduction of the global positioning system GPS to the public has provided millions of pupils with the navigation and positioning services around the globe. However, it is not how matter the improvement to the accuracy. Fundamentally, GPS cannot provide the location information in extreme environments such as underwater and undergrounds. Hence, there exists environment where GPS is no longer suitable. These less environments often include mountain regions where the line of sight, LOS, and physical obstruction inhibit the signals. So, in order to solve this problem, the system has been developed. Next is the objective of these projects. First is to develop the LoRa positioning system based on Internet of Things, IoTs. The Internet of Things means that when we get the position in the gateway and display on the computer, the data will implement in IoT designs because we want to view the position of the objects anywhere by using the Internet of Things. The second is to design the positioning algorithms for the LoRa system utilizing RSSI. We are designing the algorithm that we choose in this Arduino IDE. And finally is to analyze the error location in terms of RMSE, which is root mean square error, and the CDF cumulative density function. The CDF limitation is 90% with the less than 5 meter errors. We are analyze the RMSE, which used to measure the difference between the values. In other words, it's measure the error in the different places. While the CDF is the distribution of graph that analyze or compare the accuracy in the different locations. Next is the hardware of these projects. As you can see, on the left is the transmitter that will transmit the signal in terms of the package. On the right is the receiver that receive this signal in terms of RSSI. Next is the project setup. This is the transmitters. It has 3 transmitter and 1 receivers. And this is the gateway, or we call it transceivers. In these project setups, we change the distance each of the TS and RS, which in this case is 5 meter. It have the transmitter and receiver, and each of the transmitter are placed in 5 meter from the transceivers. For the system development, in this project, we are using the LoRa transmitter and LoRa transceiver. The data collection phase, we are using the RSSI method that transmit the signal from the transmitter to the receiver. The data are collected in 4 different environments, which are 5 meter indoor line of sight, LOS, 5 meter indoor non-line of sight, NLOS, 5 meter outdoor line of sight, LOS, and 5 meter outdoor non-line of sight, NLOS. And we are designing the positioning algorithm, which are using the trilateration methods. And finally, we are implement the algorithm connection to the IoT platform. In this case, we are using the blink. Next, the raw RSSI data from the 3 transmitter are estimates. First, the RSSI data collects from the transmitter to estimate the location of the objects. Next, the data will filter out using the Kalman filter. It will filter to improve the accuracy of the positions. And we apply the trilateration algorithm to estimate the final locations. And by using the trilateration, the intersection of the geometric circle will estimate the positions. Next, as you can see in the first picture, is the output of the serial monitor, which is on the left is the output of the transmitter, and on the right is the output of the receiver. And next, we are using the MATLABs to convert the RSSI into the distance estimation, and these are the filter using the Kalman filter. And next is the location estimations. And finally, the data will connect to the IoT platform. In this case, I'm using the blinks. And next, we are using the Kalman filter and without using Kalman filter in Excel. As you can see, there are 4 different measurement that I measure it. The first is indoor 5 meter LOS. Second is outdoor 5 meter LOS. Next is the indoor 5 meter NLOS. And finally, outdoor 5 meter NLOS. The first column is the time that I measured. The second is the 1 transmitter, 2 transmitter, and 3 transmitter that will send the data which are in term of the RSSI, and the data will convert in the MATLABs using the coding and get the distance, and by using the trilateration algorithm we get the location estimate. And this column J and K is the actual locations, and we get the error by minus the error but from actual to the actual location to the estimate location. Next, we square root the x and y, and we sum it up to get the MSE, and we find the root mean square error. As you can see, the root mean square error for the without using the gamma filter is 2.062. And finally, we get the CDF is from the XE square 2 and YE square 2. Next, we compare with using the gamma filter. By using the gamma filter, we get the distance by using the gamma filter, also the same, and the location estimate. We estimate the locations and we get the error. We also the same procedure, and we get the RMSE. As you can see, the RMSE is lower than the RMSE without using the gamma filter. So we can conclude that by using the gamma filter, it can reduce the error and get the better accuracy. And the CDF also lower than the CDF without using the gamma filter. As you can see, is for the outdoor 5 meter LOS also do the same way. The RMSE is 1.17. This RMSE is low, which is 0.329, which are the better. And this is 0.634, and this is 0.612, better accuracy. And this is 0.59, and this is 0.54, is also the better accuracies. So we go to the next slides and final stage. Finally, we go to the project significant. This project is the alternative to the satellite-based positioning system. The system can replace the GPS because it has more advantage compared to the GPS. Next, it can be an alternative to the GPS if the GPS is not usable in the positioning systems. For example, in the early history, GPS owned by United States governments and used only for the US Department of Defense. The GPS do not open to the public that day. After the incident of Korean Airlines flights that crashed, US suddenly opened GPS to the public. Somehow, the purpose of the system for the security of the country, some countries have developed their own satellite. For example, Russia, which named GLONASS. In Malaysia, there is still do not have development of the satellite system because it use a lot of expertise and money to develop. So LoRa is the alternative to replace the system. Next is the LoRa-based positioning system through the Internet of Things is the improved system. The system can be implemented in the low-sit area. Example, locate the asset management in the big warehouse, where in the warehouse, the signal is blocked because of the building, so it is difficult to locate the assets management. By using the LoRa, it can estimate the location or the accurate the location of the asset management. Next is the system can be benefit to the society by using the low signal devices. LoRa is the low cost devices compared to the GPS, so it can be affordable system for the society. Next is also be reduce the society workload, such as locate the asset management in the large warehouse. In the big warehouse, for example, in the JNT warehouse, there are a lot of parcel to deliver. It can take time to sort the parcel to the customer. It use much of the workload. So the LoRa can be used in this system. And finally, it's also environment friendly when using the device that low power consumption. As the LoRa has the low power consumption, it can reduce the usage of the power and save a lot of energy. That's all for me. Thank you very much.